researchers have collaborated to create one of the largest breakthroughs in modern robotics, a mind-controlled robot. Now, other mind-controlled computers exist already, but what makes this such an important breakthrough is that it is entirely non-invasive. This is the world's first mind-controlled robot without any sort of physical brain implants. The work was done by a team of researchers from Carnegie Mellon University and the University of Minnesota. In their pursuit of advancing the field of brain-computer interfaces, or BCIs, the researchers developed the first ever mind-controlled robotic arm which was able to successfully and continuously track a computer's cursor. This task may not sound impressive on its own. After all, there are viral videos of cats doing similar things with animated fish on a tablet. But that's precisely what makes this so important. Being able to continuously track a moving object is a motor skill we take for granted, but it's crucial for nearly every aspect of our daily lives. If someone tosses you something, you have to be able to predict and track its movements so that you catch it instead of being hit in the face. And when you're crossing the street, it's really important that you're able to track and monitor oncoming traffic. This motor skill is also a stepping stone for other, more complex tasks like moving an object to a target location. One example of this is moving a spoon to your mouth. It's a simple task, but there are a lot of things that have to work properly in order for you to eat the food instead of wearing it. It's something we take for granted, but millions of people with motor skill impairments would benefit greatly from the ability to control a robotic arm with their minds in order to regain some independence and confidence. While there are already BCIs that allow for accurate control and maneuvering of robotic devices, until now, all of them have been operated with the use of physical brain implants. These implants are expensive to produce, require highly skilled professionals to perform the implantation surgeries, and come with their own set of risks. Believe it or not, cutting open the skull to implant something into your brain isn't exactly the safest procedure. Who would have figured? Now, with the technology being developed by this team, the future of BCIs may be entirely non-invasive. At least, that's the goal for Ben He, the head of Carnegie Mellon University's Biomedical Engineering Department. Speaking on the matter, Professor He said, "Non-invasive is the ultimate goal. Advances in neural decoding and the practical utility of non-invasive robotic arm control will have major implications on the eventual development of non-invasive neurorobotics. Because there are no physical implants to receive and send the signals from the brain, the signals aren't as clear and result in lower resolutions and less precise movements." The team was able to combat and mitigate these fallbacks of non-invasive BCIs by utilizing machine learning to navigate the messy signals to find the intended signals hidden in the interference. Previously, attempts at non-invasive BCIs yielded jerky and sporadic movements. Because of the team's machine learning and sensing innovations, they were able to accurately and smoothly track the cursor's movement with the robotic arm. So far, the technology has been tested on 68 subjects, and the team is looking to open clinical trials in the near future. There are many obvious medically practical applications for this technology, but eventually, it could find uses outside of helping medical patients. Being able to control robots with our minds could allow for safer work environments and even more opportunities to work remotely by controlling machines with our minds. Professor He even suggests that one day, this technology could be as pervasive in society as smartphones.